Yankee Golf 0 EC Victor Yellow. Now for Dr. Carson, I think it's a Whiskey Uniform 2 Delta, is that correct?
That's correct. Golf 0 Echo Victor Yankee from Whiskey United 2 Delta. And the name is Mike. I'm in Manchester, New Hampshire. I think we spoke about a month and a half ago when I was playing with the Swan radio with the linear. I'm brought another radio back from the dead. This is an old Drake TR-3 from 1963 vintage. Hope you're copying, Dave. Golf 0 EVY from WU2D.
Yeah, probably you'll find very good audio on it. The TR-3 sounds great. We've got a TR-3 over here. It's called a Triumph. It's a sports car. It goes on TR-3. But anyway, nice of you to bring them back from the dead. I wonder what he died of. Did he die of the coronavirus?
So we have a couple more things we have to cover with the radio before we put the covers on. The TR-3 has been a wonderful project. I call this a refurbishment more than a restoration. We did enough to get the radio cleaned up, back on the air, and operational in all the modes. In the manual, the first thing they cover as far as operation goes is sideband operation, because that's probably why you bought the radio in 1963. You wanted to use it as a sideband transceiver in your car or perhaps in your station. But you really need to do the tune-up in CW before you get to sideband. You need to get the radio actually tuned up. So let's do the CW first. So for CW, in the manual they say that the TR-3 uses shifted carrier CW. With this system it's possible to transmit approximately on the received station's frequency without being zero beat while receiving. The receiving BFO differs from the transmitted signal by about 1 kilohertz, which allows a 1 kilohertz tone to be heard. Now, this works in theory in 1963, but in 2020 we have a little problem because people's transceivers are so narrow. Being off 500 kilohertz this way or that way is quite important. It's so important he probably won't even hear you. So be cognizant that the other guy may wonder, why are you off 300 or 400 hertz? You should be right on my frequency. And that's just normal with a radio like of this vintage with a wide IF. You don't know exactly what frequency you're on, and you don't know exactly what frequency he's on. So you take a guess till the tone sounds pleasant, you let him adjust, and then you do no further adjustments. Tune it up in CW, and you can see I've got the power meter up here now. We're going to put the sideband switch in the X position. Now that takes it to upper sideband. Oh wait, I'm on 80 meters. That's lower sideband. Well, don't pay attention to that. We're just tuning up in CW. In CW, we're always transmitting on the upper sideband. That's just the way it is. Now, this is the transmit gain control, effectively the driver control. So let's turn that down to 0. We should have already peaked the receiver. Okay, so that's step one. You got to get the RF driver at least peaked up, or you're not going to see anything. So we've done that and received. Now we're going to go to the CW position, and then we're going to slowly bring up the drive till we see something on the meter. Just a little bit. Can you see how something came up on the meter? Also, you'll notice I'm running a muffin fan on the finals. That's important while we're fooling around here in CW. Okay, so we're peaking the final. Looks like we're good. So we'll bring it up. Again, go for maximum smoke. Okay. And as you can see, this meter is way high. That's a 400 milliamps. You turn it until it doesn't go any further. That's as far as you need to go, and then come out. Okay? So we are now tuned up in CW. As you can see, we're putting out about 160 watts of CW. That's a pretty powerful output. I don't want to run that much power. If you don't want to run that much power, bring that drive down. Okay, I just want to run 40 watts. Okay, I just want to run 60 watts. Just don't stay in transmit too long. Make sure you have the muffin fan running. and you'll have no problem with burning up the finals. But as you can see, no matter what they tell you in the manual, it does take a few seconds to get this thing tuned up properly. And use the plate and tuning and load controls and tune for maximum power out. I don't like this dipping the plate thing that they have in the manual. It's just going to take too long to get it tuned up. Go for maximum output on the meter. That's the quickest way to get the radio tuned. Now we're tuned up for CW, and we can plug in our key. We now have our key. Now how do we go to transmit in CW? We just go here, and notice we're not putting anything out. No output. We have a static current on there because of the bias in the finals. So when we close the key, there it is. I don't hear any beeping. I don't hear anything. That's because the TR-3 does not have side tone for CW. Neither does it have automatic changeover. So you have to put it into CW and then transmit. So if you want to have side tone, you're going to have to use an external device like a box that has side tone built into it. So we'll do that next. Okay, we now have our keyer plugged into the radio, and we can use our test button. Now we get the side tone and we get the output. So some little odd tips with the TR-3. If you have a key plugged into the TR-3 over here at the key jack over here, and you try to use the microphone, nothing's going to happen unless you close the key. Basically, you're keying a stage in there, and unless that stage is keyed, the microphone does not work, and you get no RF. It's pretty amazing. So you have to unplug the key, or you have to close the key in order to use the microphone with the radio. So keep that in mind in case no matter what you do, you get no audio out. Also, because there's no side tone with CW, you need to use some type of a keyer or some type of device that gives you a side tone and keys the radio. Because this is grid block keying, you have to be careful with just a conventional kind of transistor to ground type keyer. You actually have to have a floating type system, usually opto-isolated, and I'll put a schematic up of how to make that interface off any standard keyer. But this is the bencher with a Curtis keyer board inside a little box. You can adjust the speed. You can adjust the level of the side tone. It has a kind of a test button, so you can just go key down if you need to. And it does conventional and iambic keying. But the nice thing about this particular keyer is I have two different interfaces on the back that go out to a terminal strip. One is for collector keying, which means it will bring a point to ground like the cathode of a tube. There's a high voltage transistor which allows you to key almost any cathode of anything up to a 6146, for instance. And then it's got the isolated output for the grid block keying, which is always a negative voltage. So anyway, you want to use the keyer. You can use the keyer with a straight key, or you can use it with a bencher paddle. Whiskey United 2 Delta.
2 Delta.
Whiskey United 2 Delta. WU2D. You're 59 in New Hampshire, 59 in New Hampshire.
2 Delta, thank you very much. I give you 57, 57 with make USB over.
Yep, using a vintage transceiver, a Drake TR-3. Vintage transceiver, Drake TR-3, and we're barefoot. 73s. Now in CW we would plug the key into the key jack, and then you'd be able to key the radio. But if you don't plug the key into the key jack, the jack automatically shorts. So when you go into the CW position on the front panel with the two X's, the radio will key. So that's what we'll do for this sideband tune-up. We won't actually use the key or the key jack. Okay, single sideband. Now on 80 meters, we need to use lower sideband. So this is going to go here. We have the sideband mode. And now we are going to go to a clear frequency, and we're going to talk into the microphone and bring up the drive as we talk until we see the S meter start to move a little bit as we talk. And that means you're into the automatic level control on the transceiver, and you don't need to have any more drive in sideband than that. We're all tuned up for CW. Okay, if we went to CW, we'd be putting out the full, 180 watts or something. But right now we have the drive control all the way down, so when we go to CW, nothing will come out. Okay, but in sideband, when we go push to talk or Vox, we will be turning up this gain until we have some movement on the S meter, and that's going to tell us that we're into the ALC range. Let's try it. This is WU2D. Okay, nothing's moving. This is WU2D. Whiskey United 2 Delta. WU2D. Whiskey United 2 Delta. Hello CQ, calling CQ, CQ75 from WU2D, Whiskey Uniform 2 Delta. Okay, let's say you want to use the radio on AM. For AM, you put the sideband switch in the X position, and you put the mode switch in the AM position. As you can notice, it's already keyed. So we're going to look at the AM mode with the TR-3. First of all, I want to operate it into a dummy load, and I've looped a piece of wire through the dummy load, grounded one side of it right to the case, and the other side is going to the scope probe. So I have a loop of wire, a shorted loop of wire, that actually goes inside a little bit to pick up some RF so that we can display it on the scope and look for an AM envelope. The type of AM that the transceiver produces is called single sideband AM. So it's full carrier, but only one sideband is going to be transmitted. And it's kind of interesting in the manual. You've got some settings that do tend to confuse people a little bit. So I realize that having the muffin fan on in the PA cage is a little bit annoying, the noise, but absolutely necessary with a radio like this with sweep tubes. I just wouldn't run one without some type of muffin fan running. If you don't like all that noise, get a 12-volt fan like a computer power supply fan, and instead of running it on 12 volts, run it on 9 volts. Or if you have a 24-volt fan, run it on 18 volts. The idea is less RPM will be less noise, and of course you're going to have less wind as well, but you don't need that much to get the heat out of the cage. Just a little bit of airflow makes a big difference with these sweep tube type radios. So let's look at AM operation. When transmitting on AM, the function switch must be in the XAM and the sideband switch must be in the X position. Then, while talking into the microphone in a normal voice, rotate the transmit gain control until the plate current peaks between 0.2 and 0.25 amps. Care should be taken to stay within these limits, since the transmitting AGC does not work for AM. Now, something very disturbing with the AM mode, and you're not going to like this. As with CW, to receive, you must be in the SSB mode. Okay? So when you're transmitting in AM, you have to manually throw the switch into the AM position and talk. Then when you're done talking on AM, you bring it back to the single sideband position to receive. This is very, very primitive. AM is definitely not what this radio was designed for. I call this a courtesy mode. So we're not expecting tremendous AM performance out of this thing, and they're kind of almost discouraging you from using the mode with the radio. Why did a ham buy the TR-3 in 1963? He bought it for single sideband, let's face it. He didn't buy it for CW. He didn't buy it for AM. He bought it for single sideband. So let's put it in the AM mode, and let's adjust the transmitter gain until we get the conditions that they called for. So that's between 0.2 and 0.25 amps. Remember, we're all tuned up in CW, and we've turned the drive control all the way down. Let's go to AM. Okay, we're going to go into the AM mode, and we're going to make sure that our plate meter is no higher than 100 to 200. Wow. See how that meter wiggles? Okay, it's a little over 100. Looks like we're putting out about 30 watts. Now let's look at the scope as we talk. Hello, hello, 1, 2. That looks like AM to me. One, 2, 3, 4, 5. Hey, it's AM, folks. That certainly looks like an AM transmission to me. So, looks like it does work on AM. And it puts out, 35 watts of AM. So, there you go. Now, to receive, I got to go all the way back to sideband. Back to AM, 1, 2, 3, 4, 5. So, there you go. That's how you use AM on a TR-3. Me for AM mode, I have to listen in single sideband. That means I actually have to zero beat the station I'm talking to be able to demodulate the AM. Let's just say AM is not the primary mode for this transceiver. So I didn't really go over these controls on the side, but we have the microphone connector. Here's your phone jack if you want to use phones on the rig. You have the Vox control, which is really the gain for the Vox. The anti-Vox, which helps with the Vox not feeding back with the speaker keying the microphone. Here's your meter 0 for your S meter, and finally your key jack down here. So you have your key jack, your meter 0, and so on. So if we wanted to do Vox, okay, we would turn this clockwise. So right now it's not keying up when I talk, but I'm going to turn the Vox up. 1, 2, 1, 2, 1, 2, 3, 4. This is WU2D testing. WU2D testing. So that's how the Vox works. Now if you have some trouble with PTT, ordinary PTT, then turn the Vox up just a little bit, like maybe 5 degrees, and that will help that tube to switch from transmit to receive. So I'm very close to buttoning the radio up and getting it ready to ship off, but I did have one question, and that is, when you're going from upper sideband to lower sideband, there's a section in the manual in the alignment that talks about making the noise or the rushing sound out of the speaker sound similar as you go from lower to upper sideband. Now you can clearly hear that that's two different tones. The place where you make an adjustment for upper and lower sideband as you tune is done with C130 back here, which is the carrier oscillator trimmer. And you rock that until you find the sweet spot from going to lower to upper sideband and having the voice sound natural. And I've done that with this radio, but as you can hear, we never quite get to that point where the two sound exactly the same as far as the tone goes. And that has to do with the aging of the crystal filter, of course, and how the crystal filters are coupled into the circuit. So I don't think you can hope to get it absolutely perfect, but you can get something that will work on upper and lower sideband, and it'll sound okay. But I was not able to reproduce what they asked for, and that causes a lot of people to go crazy when they go through the alignment. So it's been a long time waiting for this. We got the bottom cover. I went as far as to get some replacement black screws. The ones that were on the radio were pretty rusty, so I've got some nice new black pan head screws with the flat screwdriver drive. They're going to look nice on the radio. So I think the radio really cleaned up nicely. The power supply came out good. We learned about all of the good points on the radio as well as the warts and the things that maybe we think are inconvenient. Remember, the purpose of this radio was to deliver a single sideband transceiver, mostly for mobile operation, and CW and AM were just there as little trinkets on the radio. This is a sideband transceiver, one of the first practical sideband transceivers. Fancy features such as automatic noise limiting, automatic CW changeover, Vox, receiver incremental tuning, this would all come along. But this is the guy that got it all started in the low-cost transceiver market of the early 1960s.